Hello and welcome to LFI Educate. Let us study about the motion of vehicles in a level and banked road, B-A-N-K-E-D, banked road. When it takes turn, then at what speed you have to take the turn so that you will not get skidded off from the road to avoid accidents. Vehicle on level and banked roads. Let us see first case 1. On a level road we will see first case 1. Vehicle on a level road. So how it should take the turn? Level turning road. We are talking about how to take the turn. Let me draw one road like this, having a turn. This is your road, suppose. Then this is the level ground. Then you have one car here. What type of car do you want to take it? Suppose this is your BMW or Ferrari. Anyone you can take it is moving, suppose, with some velocity on the road. This is a front view. Don't misjudge it. This is the front view of the car. The other part of the car is like this, suppose the tires are here. It's coming on the road. So we'll take like this. Let a car of mass M moving with a velocity V, moving with a velocity V. Then here you have, as there is no vertical motion, I'll write down here first, as there is no vertical motion of the car, the normal reaction is equal to the weight mg of the car. Here the normal reaction, we know that will be acting in downward direction, mg. Suppose if I am standing here, then this is me, suppose standing here, normal reaction will be upward and weight mg will be acting downward. So here is your weight mg, and a normal reaction you have been using R or N? R. Let me write it as R. So in this case R and mg will be balanced because the car does not go above the road or under the earth. So there is no vertical motion. That's why it will remain the same. Mg of the car, so R is equal to mg. I'll write equation number 1. Now the car is about to turn, suppose, as the road is having the turn U-shaped or circular motion is there. When the car tries to take the turn, when the car takes the turn, and as we already learned, whenever a body is in circular motion, then a centripetal acceleration will be there. They will be acting towards the center of the circular path, and there will be centripetal force as well. You can remember, I think. So this is the turning. So there will be a center here. So I have to erase it. This part I have to erase it a bit. This is the center of the circular path say. Then the centripetal force will be provided by the force of static friction here. Centripetal force Fc will be equal to the force of static friction provided by the rod to the car in the tire. So when the car takes the turn, the necessary centripetal force is provided by the force of static friction Therefore, the necessary centripetal force will be provided by the force of static friction. So Fs will be equal to Fc. Now Fs is equal to centripetal force. Your expression is mv squared divided by r that you learned in chapter 4, motion in a plane. You can check it out. But we know that force of static friction is always less than or equal to the normal reaction. Force of static friction is always less than or equal to the force of coefficient of static friction into the normal reaction R. And R value we know that it is mg. So Fs is less than or equal to μs into R. R is in the diagram is equal to, from equation 1 it is mg. So we can make it as equation number, this one we can make equation number 2, this one we can make equation number 3. Now putting the value of equation 2 in equation 3, putting the value of, this is R is equal to mg. Putting the value of equation 2 in equation, putting the value of Fs from equation 2 in equation 3, we get Fs value is mv squared divided by r is less than or equal to mu s m into g. Here we will be thinking what is r. The r is the radius of the circular path. This is r. R is the radius of the circular path. Here r is the radius of the circular path. Now here mm you can cancel it out and then you can get the expression for velocity. Then v square is less than or equal to mu s acceleration due to gravity and radius of the circular path. Or you can write v, if you remove the square, is less than or equal to mu s gr under root. This is your expression. That means at this, depending upon the radius of the circular path, you will have to drive the vehicle. At what speed you have to go so that you don't get skidded off. Skidding off means, suppose like this car, if it is skidding off, you will go off the road. You go in another direction, you will not catch the road. So this is the velocity with which you will have to take the turn. Here it is less than or equal to means it should be less. Your speed should be less than this value what you calculate and get it. If it is more than that, then you will get skidded off. Skidding off means to go off the track. But the maximum value of V maxima, the maximum speed at which you can go is, you can take equal to also. then you will get the maximum velocity with which you can go around the circular track. Only we write equal to, and it's overall. Either it should be equal to or it should be less. More than that, then the car will get skidded off and will meet with an accident. So like this you can find out for a level road. That means in the turn the road is leveled. Now the second case we will see if the road is not level, if it is banked, then there is advantage we know. Whenever there is a turn, when you go in a highway, you will find that the roads are not flat like this, little bit it will be banked. Then in that case, with what velocity we can travel on the road, that we can calculate it. In the second case I'll do it. Now let us see case 2. Vehicle on a banked road. Suppose this is your road and then you have banked the road. This is your banking. Angle is here, theta. And the car is here, suppose. This is the front view of the car. Tire will look somewhat flat. This is your car. This is the front view of the car. It's moving on the banked road. Then in this case, the forces acting on it will be, these are the forces that will be acting on it. One will be the weight mg, weight of the car. One will be the normal reaction, that is R, perpendicular to the banked road. And one will be the force of friction with the tire. It will be decided. I take another point here. Then this will be the force of friction. I'll write it as Fs. Fs. Now the forces acting on the vehicle are: number 1, the normal reaction, that is R. The second one, the weight mg. And the third one, the force of static friction. That is Fs. Now in this case, you can see very clearly that the force of static friction is not pointing towards the center of the circular path. It's pointing somewhere else. So we need to resolve it. Fs, on resolving, you will get like this, one component that will be pointing towards the center of the circular path. Center is somewhere here, suppose O. That will be, if this is theta, this angle also will be theta. So towards theta it will be Fs cos theta. And one perpendicular component will come like this, that will write it as Fs sin theta. This will be Fs sin theta. And then we'll resolve this R also into the rectangular component. From the vertical component, if this is theta, then this angle is theta, this 90 minus theta, so this angle will be theta. So if this is theta, then it will be R sin theta, R cos theta towards the angle base, R cos theta, and then this side it will be R sin theta. Like this will resolve Fs as well as will resolve the normal reaction R. Now on resolving, Fs into their rectangular components, one will get Fs by resolving it. So one will get Fs cos theta and the other one you get Fs sin theta. Fs cos theta is the parallel component, parallel to the ground, ground before banking. This is the parallel component. Fs cos theta, the parallel component, and Fs sin theta, the perpendicular component. Likewise, on resolving R into their components, one will be R cos theta, the perpendicular component, R cos theta, the perpendicular component, and the other one is R sin theta, the parallel component. Like this you have to resolve it first. After you resolve it, then what we'll do is, first of all, as there is no vertical motion of the car, this R cos theta will be equal to sum of Fs sin theta and mg together. So, as there is no vertical motion of the car, mg plus Fs sin theta will be equal to R cos theta, and mg is equal to R cos theta minus Fs sin theta. This term, transpose it towards the right hand side. mg is equal to R cos theta minus Fs is equal to mu s into R, a normal reaction, sin theta. Like this, we find equation number 1. Now after this, the centripetal force is provided by these two components. You can see it's acting towards the center. The centripetal force is provided by sum of R sin theta and Fs cos theta. Therefore, Fc is equal to centripetal force. Fc, if I write centripetal force, that is equal to R sin theta plus Fs cos theta. Here also Fc is, now we will write down later on. Fc is equal to R sin theta plus Fs is equal to mu s into R cos theta. Make it like this. This is equation number 2. But we know that in this one we'll do like this. Fc is mv squared divided by R equal to this R sin theta plus mu s into R cos theta. Let us mark this as equation number 2. Now dividing these two equations, equation 1 and 2, Dividing equation 2 by equation 1, you'll get mv square divided by r, you're dividing by mg, is equal to r sin theta plus mu s r cos theta divided by r cos theta minus mu s r sin theta. This one mv square divided by r into mg. This one we get upside down, come downside. R if you take common, you will get sin theta plus mu s cos theta divided by r is common, cos theta minus mu s sin theta. So this r cancel it, m cancel it, you will get v square divided by rg. Here dividing by cos theta, numerator and denominator will do like this, sin theta by cos theta plus mu s cos theta by cos theta will get cancelled, divided by cos theta by cos theta minus mu s sin theta by cos theta. Here also will get cancelled, you will get 1. So it will come out like this, v square is equal to, or v square by rg, let us write v square by rg is equal to tan theta plus mu s, tan theta plus mu s divided by 1 minus, this is 1 minus mu s tan theta, mu s tan theta. Now you can write v square is equal to rg, you can cross multiply here, then it will be tan theta plus mu s divided by 1 minus mu s tan theta. Then v will become square root of, or under root, rg tan theta plus mu s divided by 1 minus mu s tan theta. So this will be your final expression. This is the maximum velocity. Actually this is, it should be less or equal to. Maximum velocity is the expression that we got it equal to, right? This is r into g tan theta plus mu s divided by 1 minus mu s tan theta. This will give you the maximum velocity at which you can turn in the banked road. And again, if a special case is there, if write a special case, if there is no friction, suppose the tire worn out completely, it is fully flat. Flat means that it has become smooth. The tire became very smooth, cannot provide friction with the ground. Then in that case, this component mu s will not be there. The coefficient of static friction will become 0. In that case, v will be equal to root over rg tan theta. Only this will remain, tan theta. This is 0, this is also 0, so tan theta by 1 will be tan theta. So if no friction is provided by the tire on the ground, then this will be your expression. This we call this optimal speed also. Now the angle of banking, this one theta also you can find out from here. The angle of banking to find out, squaring on both sides, v square you will get rg tan theta, and tan theta will give you the angle of banking, V square by Rg, or therefore theta is equal to tan inverse of V square by Rg. Like this you can find out the angle of banking, theta. So if you know the formula, if you put it in the proper places, then you can calculate it, the maximum velocity at which the car can take the turn, then what will be the optimal velocity, that is without friction, what is the angle of banking, provided you know V, R and G, you can put the values and you can calculate. Let's solve this simple numerical here. You have to solve many more questions related with the formulas that we have derived. A circular racetrack of radius 300 meter is bent at an angle of 15 degree. If the coefficient of friction between the wheels of a race car and road is 0.2, it's a bent road. So what is the optimum speed? Optimum speed means if there is no friction, then what is the speed asking? So first one will do like this. The optimum speed V naught also we write. V is equal to root over Rg tan theta. Put the values and calculate. Radius is 300 meter. G value for convenience will take 10 meter per second square, and tan theta. Tan theta is 15 degree is the angle. Bank angle of banking is 15 degree. So this is 3000. 300 into 10, 15 degrees equal to 0.27, sorry, this is not degree, 0.27. You will multiply and find out the square root. 3 7s are 21, 2 in hand, 3 2s are 6, 7, 8. Then we have 4 zeros, sorry, 3 zeros, after decimal 2 digits, so 2 zeros will get cancelled. Then 810, if you find out the square root, 2 2s are 4, 3 3s are 9, cannot come, 4. 1 0, then plus 2, which is 4. 4 8 times, let us see, 8 is 64, 8 4 is 32, 38 is closer. 8 I'll take, 384. 10 minus 4 is 6, 10 minus 8 is 2, and 0 0, if you write decimal will come, plus 8 is 16, 6, 1 in hand, this is 5. So 5 6 2 times, let us see, 2 2s are 4, 2 6 are 12, 2 1 in hand, 2 5 are 10, 1 11, smaller, 5 6 3 times, 15, 5 4 times, 5 4s are 20, 5 times or 4 times you can take it. Let us see 4 times how much it will be. 4 4 16, 24 25, 4 5 is 20 plus 2 is 22, 2 2, yes it will come, 4 times will come, around 4 times. So 28.4 meter per second, the SI unit you write down. And then the second one, maximum permissible speed to avoid slipping. Maximum permissible speed, the second one, maximum permissible speed, V maxima. Your formula is root over Rg mu s plus tan theta divided by, you can take the bracket as a whole, 1 minus mu s tan theta. Put the values. So V maxima is equal to R, the radius. If the coefficient of friction between the wheels of the radius is 300 meter, this is 300. G value for convenience we are taking 10. Mu s is given 0.2 plus tan theta, tan 15 degree, divided by 1 minus 0.2 into 10, 15 degree. Then this will be 3000 into 0.2 plus 10, 15 is 0.27. divided by 1 minus 0.2 into 0.27. 3000. If you add it, it will be 0.47 divided by 1 minus 0.27 into 0.2, 1445 for decimal 3 digit, so it will appear like this. 1 minus 0.054, then you will have 3000 into 0.47 divided by 1 minus 0.054. 10 minus 4 is 6, 9 minus 5 is 4, 9, 0.946, 0.946. Then remove the decimals first of all. Right here, maximum speed will be 3000 into, if you write this as 47, after decimal you have 2 digits, if you write 47 divided by 100 into 946. 946, if you write on the top and multiply by 1000. These two zeros will get cancelled. Then multiply, 3 sevens are 21, 3 fours are 12, 13, 14, 141. Then you have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros divided by 946. First divide and then you will find out the square root. 1410000 divided by 946. 4 digit we have to take. 1 time it is 946. 4, 10, 4, 6, 13, 9, 9, 4. Then this is 0. Can bring down. After that, 9, 5s are 9, 6 are 54. 9, 5s are 45. 9, 5, 4 times you can try. 9, 6, 4, 5, 4 times. 4, 6 are 24. 16, 17, 18, 8, 1, 11, 6, 37. 9, 6, 9, 4, 6, 5 times, 30, 23, 2 in hand, 45, 46, 47. This is bigger, you cannot take, 4 you have to take. Then you get 3, 7, 8, 4. 10 minus 4 is 6. 13 minus 8 is 5. 15 minus 7 is 8. Then again 1, 0 you can bring, this one. Then 9, 4, 6, 8 times 72, yes, 8, 6 is 48, 32, 36, 3 in hand, 72, 75, 9, 6, 9, 4, 6, 9 times, 9 9 is 81, 9 6 are 54, 36, 41, 4 in hand, 81, 85. This also will come 9 times. This is 8, 5, 1, 4. Then subtract it, 10 minus 4 is 6, 5 minus 1 is 4. Then again this last 0 will bring. Cannot do one time. So you put 0, then decimal. Then one more 0 you can write. Then again 946. Then 4 times will come. Like this you can find out. 4 times it will be 3784. So you will get the value like this, 1490.4. Then you find out the square root. 1490.4. Before decimal 2 digit, 4 4s are 16, 3 3s are 9. Okay, 3 3s are 9. 5, then 9 0 you will bring down. Plus 3 is 6. 6 times 6 6 are 36, 39, small. 6 8 times 4 8 are 64, 48, 49, 54. So come 8 times it will be 5 4 4. 10 minus 4 is 6, 8 minus 4 is 4. Then decimal, so we'll put decimal here. Then 4 alone cannot bring, you put 1 0 and bring together. 40 plus 8 is 16, 6, 1 in hand, this is 7. 7 6 are 42, so 7 6 times to the C, 36, 39, 42, 44, 45. 6 9s are 7 6 are 42, 44, 45. Yes, it's coming very nicely. 6. It is 4, 5, 9, 6. Then you can carry on, but after this one digit if you get, better stop. It will be 38.6 meter per second. Like this you calculate it. Little bit calculation you have to do, but if you know the formula, then it's not difficult, you can do. Thank you and have a nice day. Stay tuned with LFI Educates.